start this once again, this live video. So today I'm gonna show you how you can do a multi-label classification. So moreover, it is going to be a live video. And if you have any question, you can also, ask your question. You can leave your comments in a comment box, and I will try to answer those questions. All right. Perfect. So here I have already opened this dataset in my browser. It says that this is a StackSample and it has a 10% of Stack Overflow question and answer. And the data size is pretty much huge. And if you want to download this data, then of course you have to log in this Kaggle. But I have also uploaded this data at my GitHub repository. You can check my Git repo here. All right, GitHub Lakshmi made it. So there you can check it, and you need to come here in repositories. There is all CSV ML data files download, and there I have uploaded just few hours ago. Let me see it here. Somewhere you will see there Stack Overflow.csv. So this is a Stack Overflow. All right. And if you click on view raw, then you would be able to saw all those data in raw format. All right. And this is a link which we will be using here to read this data. All right. So this data has text data and the tag. All right. And how I process this data, let me tell you. I had downloaded this huge data. All right, so this is around the 3 GB of the data. And then I did some pre-processing. And after those pre-processing, I had uploaded it on the GitHub so that everybody can use it. All right, otherwise preparing this data set directly from after the downloading on from this Kaggle site is really very difficult. All right, and for that purpose, what I did here, I did some pre-processing and then uploaded it on a GitHub. So let's go ahead and get the link of this file from here. And the pre-processing which I did, you can also get that from my GitHub repository here. So at this Git repo, sorry, what is this? At this Git repo, you have here pre-process KGP Talkie. All right, so this is a pre-process KGP Talkie package. I have prepared this package for the ease of pre-processing. Many people feel, feel that it is very tedious and difficult task to do a pre-processing. That is why I have, made this one, and it's really very simple to use. So you need to install this pre-process package. Thereafter, you can simply call this function. Then it will automatically do all the pre-processing in your data set. Like it will do the pre-processing like contraction to the expansion, email removal, URL, HTML tags, retweets, all those things it will be done. And if you want to take a very detailed course on the NLP, then of course I have here a course. You can visit this course and you can learn about the NLP in very detail. All right. Perfect. Superb. All right. Let's come back to this stack. The StackSample, this code, and all right. So here I'm gonna use a Google Colab. Why I want to use Google Colab? Because Google Colab provides a free GPU. All right. Although we will not be using a GPU, but still for the simplicity so that you can also use directly, I'm gonna show you how you can do it on Google Colab. All right. So first of all, you have to create here a new notebook. All right, in this new notebook, it might take a while. Let's go ahead and wait for a few seconds. All right, so while it is preparing all those things, let me do some settings. Just a second. All right, so what I'm going to do here, I'm going to rename it, and then I'm going to rename it to sorry, it's actually the multi-label. It's not a multi-class, it's a multi-label classification. All right, so this is a multi-label classification, and then I'm going to click on connect, although it automatically get connect. All right, so this is a multi-label classification. Let me bring this header file here. So first of all, I'm going to add here this text, and I'm going to put it heading 1. All right, so this is multi-label classification. All right, so in this multi-label classification, the first of all, I have to, load our data set. And to load the data set, what I have to do here, I have to import pandas as PD. And I have to also import numpy as NP. All right, I have just received here a message, Rahul. Hi Rahul, how are you? All right, thanks for watching it. If you have any question, please go ahead and ask. All right, so we have imported here pandas and numpy. Thereafter, we are gonna load this data set. So let's go ahead and copy it, and you can directly load the data set from the web. So here we have a pd.read CSV, and then we need to give here URL from where we want to read. Let's go ahead and see. So this data is actually huge, and it took a little time to download it. And it says that there is a default numbering system. That's mean this is a index, and we need to put this index in an index. And for that, I have to put here huge, I have to put here huge index actually. Sorry, it's index huge. It's index column. Now I'm going to say that huge index column is equal to the 0. And now you can see here properly it is printed out. All right, perfect. Let's go ahead and read it into a data frame df. And now we have read it into a data frame df. Thereafter, we can do here df.head. So this is head of this data frame. It has a text data and the tag. All right, and this text data is actually coming from here Stack Overflow. And if you see this data, it has here these column. All right, in these column, let me show you. So in these column, it has here body. So body was actually, let me show you on the Stack Overflow itself. All right, so there we have a Stack Overflow. In this Stack Overflow, let's go ahead and search like a Python. So what happened here? This is your question. In this question, you have here a title and this is your body. So what I have done here, I have put this body and the text data together to just pre-process our data set. All right. Perfect. And one more thing, let me share this, the notebook link here so that you can also follow. And let me share it here. All right, so that everybody can follow it if you are following this lesson. And I'm gonna change here this link setting to everyone, anyone with the link. All right, let's go ahead and copy this link. And let me comment it here. All right, so now I'm sure you should be able to see this. All right, Google Colab notebook. And if you are not able to see this, let me know. If I need to make some changes, I'll make those changes. All right, so just received a message from Short Wine. Hi, how are you? All right, superb. So this multi-label, let me fix it to like multi-label text classification. All right, so it's gonna be like multi-label text classification. Perfect, superb. All right, let me bring it into a full mode. So there we have now multi-label text classification. All right, so we have got our data frame, and thereafter what I'm going to do here, once we get this data frame, we need to now start pre-processing. So here I'm going to use TF-IDF. TF-IDF is term frequency and inverse document frequency. All right, but before we use TF-IDF, few more things, let me show you that. This tag, if you see there, this is actually this is a string. All right, so let me show you how I'm saying that this is a string. So there we have here tags, and then I'm gonna show here iLock0. And if you notice that this is a string, and apart from that, if you check the type of this first index, it says that this is a string. But we want it to make a list. All right. So to make a list, we have to evaluate this function, and how we can do this evaluation. For that evaluation, we have to import here AST. All right, so this AST will do a literal evaluation. Thereafter, if I use here AST dot literal eval. All right, and in this literal eval, I'm gonna use this one so that you can see it here, how it is working. And yes, now you can see properly here what is the difference here. Let me print that one here as well. So the difference, if you notice there, this one is a string and this one is a list. All right, so this is this is literal evaluation which we need to do here. All right, hi Prem Kumar Jha. So I have just shared here a link for this notebook. All right, go ahead and see in the comment box. The link is available there. All right, so as.literaleval def tag iLock. Let's go ahead and change these string data in the form of list. And to do that, I am going to use here a lambda function. So as tags def tags dot apply. There I have a lambda function. So how this lambda function work? Lambda function iterate over each row, and then the row data is placed inside this X. Thereafter we need to perform this operation. All right, so as.literaleval. So I'm going to do here ast.literaleval and then X. So this is going to change all these the tags data in the form of list, and you can check it with the head, and this head says that now it has converted in the form of list. So with the very clear, it is here that we are dealing with multi-label text classification. Now, do you know the difference between the multi-label and multi-class? Let me show you here a multi-label versus multi-class. And if you see in the image, you will notice that. And this one is a perfect example for multi-class and a multi-label. In multi-class, only one output can be true, all right, at any time. So this is example of multi-class, but in the multi-label, many output can be true together. For example, here it has a cloud, and this is a sun, and there is a moon. But in multi-label, a sun and cloud can be together, and these two are true here. And then a moon, only a single label can be true there. And then we have here once again a multi-label where all those labels are true together. So this is the beauty for this multi-label. And there is another one for a multi-label. So in a multi-class, we can select only one at a time, but in a multi-label, we can select here a multiple animals together. So this is the same thing we are doing here. In multi-label, we can select here a multiple tags. That means we can predict here multiple tags together. All right, so this is the data frame. We are done with string data to a list conversion. All right, thereafter, now I'm going to show you how you can convert this in like a the one hot encoding. So for one hot encoding, we have here a multi-label binarizer. All right, let me show you how you can import necessary Python packages which we are going to use here. All right, so the first of all, we will be using here TF-IDF Vectorizer. So from sklearn dot feature extraction dot text import TF-IDF Vectorizer. All right, thereafter once again from sklearn dot pre-processing import multi-label binarizer. All right, we need this multi-label binarizer for a multi-label classification. And then from sklearn dot model selection import train test split. All right, perfect. Thereafter, I'm going to show you how you can import the machine learning algorithm which we are going to use in this lesson. So from sklearn dot linear model import SGDClassifier. From sklearn dot linear model import LogisticRegression. So I'll be using here a stochastic gradient descent classifier and LogisticRegression. LogisticRegression. And then I'll be also using here linear SVM. All right, so from sklearn dot SVM import linear SVC. All right, so these are the machine learning algorithm which I'll be using here in this lesson. Thereafter, we are going to have here OneVsRest classifier. Why we need OneVsRest classifier? Because we are using here a logistic regression and multi-label classifier. So we'll be taking one class at a time, and then we will be also classifying one class versus other class. So for that, we need from sklearn dot multi-class. All right, import OneVsRest classifier. All right, perfect, superb. So these are the machine learning algorithm which we will be using here, and OneVsRest classifier will do a classification one class versus other class. All right, perfect, superb. Now let's go ahead and convert our tag in the form of one hot encoding. All right, let me add few code cell here. There are all right, so the first of all, I have to get here y is equal to data frame dot tags, and if you see this y will be here a series, and these are the series for the tags. And then this y, we need to convert it into a multi-label binarizer. So let's go ahead, first create here a multi-label binarizer object here, and I'm going to say here it's like multi-label is equal to a multi-label binarizer, and then y is equal to multi-label binarizer dot fit underscore transform, and there I'm going to pass here y. Otherwise I can directly pass here like this one, tags. All right, now if you check your y here, so you have got your y in the form of like one hot encoding. All right, and if you check there, this was the example like this one. All right, and the classes here, if you want to know what are the classes in which this y is the got converted, you can also check those classes with this one, multi-label dot classes here. All right, so these are the classes, and do remember I had just the chosen top 20 classes for from this Stack Overflow data, because this data was huge. It was a 3 GB huge data, and it was taking a lot of the time for a training. And in a live classes, we cannot wait for an hour to train our model. So here I'm gonna show you the way how you can train it. Thereafter you can use your full data so that you can test it in the offline mode, and you will be free to wait for an hour to complete its classification. Alright, now these are the classes, and if you want to make it like in the data frame, you can also do that one, pd.dataframe. And if you pass your y here, you will get your data frame like this one, and thereafter you can also pass here columns name, and this column name are these one. Alright, so this is like this one. You have .NET, Android, ASP.NET like this one, and this has been converted it like in one hot encoding, and a multi-label classifier expect a target variable like this one. All right, perfect, superb. So we have got our y, that's mean we have prepared our y data set. Now let's go ahead and do our TF-IDF Vectorizer. So how this TF-IDF Vectorizer work? The TF-IDF Vectorizer is term frequency multiplication with inverse document frequency. So here I have a TF-IDF is equal to TF-IDF Vectorizer. Thereafter I have here analyzer, and let me show you a few details in this TF-IDF Vectorizer. So in this TF-IDF we have, these are the input parameters which we can use. By default, this analyzer is equal to word is selected, although you can also change it to a character level. Alright, but by default, I'm also gonna select here word. And if you want to test it, then you can also change this. Let me show you this analyzer here. So it's a character. Alright, if you select a word analyzer, it will do a tokenization word by word, but if you select a character, then it will do the tokenization character by character. And this character word, this is the character word boundary. So it will do the tokenization with character by character, and it will also detect these word boundaries. Alright, perfect. Thereafter, I'm also gonna select here max features. So this max features will make sure that we should not select the dictionary size more than a max feature selected. So by default, I'm going to select here 1000. Once again, this is a live video. So in the live video, we can't wait for an hour to complete the training. Alright, so that is why I'm going to select here a small number of feature so that we can train it just in a few minutes and we don't need to wait in this live video. So a max feature is selected here, a 1000. But you are free to change it to 2000 and 10,000, and a larger max feature you select, it will contain a larger dictionary representation for your TF-IDF. Thereafter we have x is equal to TF-IDF, it's TF-IDF dot fit underscore a transform. Alright, so it's gonna transform the data. And what is the data? The data is stored in the text. Alright, and this text is having here title and a body of a question. Alright, so there I'm gonna pass here df.text. Alright, perfect. Let's go ahead and run it. And apart from that, let me ask a question to you. I have already shared a link for this notebook, but I'm not sure that these codes are being updated in those notebooks or not. If you are able to see those notebooks with these updated code, please let me know. Alright, so a TF-IDF is done here, and we have here X data. And if you check this X is a sparse matrix. Alright, and thereafter, if you check here this TF-IDF and you need to put here a dot, thereafter it will suggest you these classes which you can use here. These classes says that these are the some, these inputs, these classes, these methods which we can use on this TF-IDF Vectorizer. And this one is also having here the stop word says that which stop words we are using in this TF-IDF, and this vocabulary says that what are the features which it has learned here. All right, you can check it here. All right, thanks a lot for updating me. All right, so here it has a TF-IDF vocabulary, and these are the words which this TF-IDF has selected. All right, and this is the full vocabulary, and it is limited to only 1000. All right, perfect. Let me comment it so that we can save space here. Otherwise, it was printing pretty much a large print there. All right, so this vocabulary is showing us actually what are the word which this TF-IDF Vectorizer has done the tokenization. All right, so we have our X, and if you check the shape of your X, you will get the data something like this one. So it says that in our DF we have 48,976 rows, and each row is having 1000 feature, and this feature is limited to here. All right, if you change this feature, then this will change here. And at the same time, we have y.shape. This y says that of course the rows will be always same, and it says that we have a 20. That's mean we have a 20 column, and those are the 20 top 20 tags from a Stack Overflow. So our X data and Y data is ready. Now we need to do train test split. So how we can do here train test split? You can write there train test split. This train test split takes X as an input and then Y as an input as well. So X is a input variable and Y is a target. So X is a feature, Y is a target here. And then I'm gonna say here a test size. This test size I'm gonna select here 0.2. Thereafter I'm also gonna select here a random state. Random state is 0. Thereafter a stratify. So stratify is equal to Y. A stratify will make sure that we divide in equal ratio in train and test data sample. And this train and test returns here X train data and X test data, Y train data and Y test data. All right, and then it says that at least populated class in Y has only one member. So what happened here? When I had given here stratify equal to Y, and I told you that it tried to divide the train test split in equal ratio as a 0.2 test size here. That's mean a target variable Y. But what happens if your target variable is having only one class for a particular class or for a particular label? Then in that case, it cannot divide that 0.2 of that label in a test set and 0.8 in a training set. All right, so for that, we have to remove it. Do remember, you need at least 2 class for each label. If at least 2 instance for each label if you want to use here a stratify. All right, so there we have got our X train and Y train. So X train and Y train is done. Sisir Maharaj is asking a question here. While using TensorFlow keras tokenization, does the same thing of converting the words? Yes. So the TensorFlow keras tokenizer also do the same thing. All right, and I'm not using here these tokenization because when you did TF-IDF Vectorizer, it doesn't preserve the ordering of any text data. So if we lost the ordering of the text data, in that case, we can't use the deep learning or keras, because in the deep learning, ordering is order of feature matters. But in the classical machine learning, orders of features doesn't matter. All right, even I would like to just add few more comments here. In a TF-IDF, if you don't want to use a TF-IDF, you can make your own algorithm for TF-IDF. It is pretty much simple. TF-IDF is term frequency multiplied by the inverse document frequency. I have here, the very good, I think the 3 hours of a lecture on the YouTube for a complete text pre-processing. In that complete text pre-processing, I have shown there how you can use your own algorithm to convert how you can use your own algorithm to generate a TF-IDF vector. Alright, so we have here our X-train, Y-train dataset. Let's go ahead and use our machine learning algorithm. Let me add few more code cell here. Alright. Alright, so let's go ahead and build our model. So we have already imported a 3 model from Scikit-Learn. If you remember, we have here SGD, logistic regression, and linear SVC. So we are going to use those SGD, logistic regression, and SVC. So here I have SGD is equal to SGDClassifier. Alright, and this SGDClassifier, this is a stochastic gradient. All right, if you put your cursor here, it says that this is a a stochastic gradient descent model based on the stochastic gradient descent learning. All right, so we have here SGD. Thereafter, LR is equal to, we are having here a logistic regression. In this logistic regression, if you notice inside this logistic regression, let me see here. There it says that, let me show you a very important part here. Somewhere it's a solver. Yes, so there is solver LBFGS. We can use either LBFGS, and many other type of the solvers are available. All right, if you notice here, let me show you the solvers. Solver also matter there to define here. So these are the solver. For a small data set, liblinear is a good choice, whereas SAG and Saga are faster for large ones. For a multi-class problem, only Newton, SG, SAG, and Saga LBGF handle multinomial loss. Liblinear is limited to OneVsRest scheme. Alright, so these are the method which we can use. So let's go ahead and use our by default LBFGS. So we have to put here a solver is equal to LBFGS. Thereafter, we have few more features here which I'm not gonna use much there, but you are free to use those as well. So those are like C values. So C is inverse of regularization. All right. Thanks a lot, Sagar. Really, I appreciate it. Thanks a lot for watching. All right. Thereafter, so let's go ahead and leave as it is all other things. Thereafter, we have here SVC. SVC is equal to linear SVC. All right. So there we have linear SVC. So we have got our model SGD, logistic regression, and SVC. Now we are going to iterate one by one. So it's pretty much simple. For classifier in, and I'm going to create here a list, and those lists are SGD, and then a logistic regression, and then I have here SVC. All right, and then here we have a CLF, and CLF is equal to OneVsRest. Do you remember that when I started this lesson and I was importing the OneVsRest, I told you that we have to use here OneVsRest so that it can classify one class accuracy. So we are going to use that here OneVsRest classifier. That means here we have a 20 classes. In the output. In those 20, it will select one at a time, and then it will take other 19 as all other classes, and it will do the same thing for everyone. Every other every data. All right. Let me see. I think I have lost the internet. I'm not sure why. Are you able to see? Let me know. I'm not sure whether you are able to see at my computer. It is saying that we are not able to connect. Please let me know if we are connected. All right, so that I can, they start immediately without trying to see the internet connectivity. All right, guys, let me know. Please let me know if you are able to see, because in my computer it says that we are not connected and YouTube is not receiving. All right, so yes, you are getting the data. All right, that's okay. Superb. Now let me start. So here, Rishabh Kapoor is asking that all right, I think connected. All right, so I have got here the excellent connection. So that's mean I'm connected here. All right, superb. Perfect. Everything is okay. Not a problem. Let's go ahead and get started with this, the coding. So I was, I was saying that Rishabh is, interested in to know more about the SGD. Rishabh, today we are talking about the multi-label text classification, and if we go in algorithm by algorithm, it will really take a lot of the time. So definitely I'll keep in mind that I'll try to make one more video on the SGD classifier as well. All right, perfect, superb. Now let's go ahead. So here we have a CLF is equal to OneVsRestClassifier. All right, thereafter, what I'm doing here, CLF OneVsRestClassifier. Now in this REST classifier, we have to give the link for our estimator. So what is the link for our estimator? Just wait a second. All right, so here start this once again, this live video. All right, so CLF dot fit. Thereafter, we need to provide here x underscore train and then y underscore train. So with this, it will start training the data. It will start the training this model, and thereafter let's go ahead and run it. But here is there is a slight problem here. What is the problem happening here? We are dealing with the multi-label text classification. All right, although I have run it, but I have to stop it and I have to explain you few more things to make it understand. All right. So to do that, what I have to do here, I have to, take you on a link there. Let me take you on a link so that you should be able to understand this multi-label. All right. So in this multi-label, we have here multi-label classification. In this multi-label classification, it says that if you know, the notice here is that multi-label classification problem must be assessed using different performance measures than a single label classification problem. All right. Perfect. So what does it mean? It says that we cannot use those methods which we have been using, like metrics.accuracy and other methods. We have to use something else, and that method is here Hamming loss and you know, this Jaccard similarity. All right. So what is this Jaccard similarity? Jaccard similarity, or this Jaccard index, is a size of a intersection of the predicted labels and true labels divided by a size of the union and predicted and the true label. How you can know it? Let me copy this term so that I can show you some images to understand, to make you understand. All right. So there I have here. All right. So I think I'm having really very slow internet. I don't know why this happened. I was having good internet, but suddenly it dropped. All right. All right. So here we have got this Jaccard similarity. In this Jaccard similarity, what we can see there, let's say if you have the two classes here, this one class and another class, it is now being as a multi-class. So what happened here? We calculate the ratio, how much intersection it is coming, divided by, all right, the union. That means, let's say if you have you know, the two classes, in those two classes we will see that how many predictions are true for that two classes divided by how many classes or how many predictions are for those two classes. All right, so it's like the intersection for the classes which we are predicting divided by the union of those classes in how many classes and in how many labels are those classes. It might be a little confused. It might be a little confusing at first when you start, but let me make you once again here. So it says that, let's say if we talk about, can we see here two classes together? I think we can see here. All right, let's say if we have these two classes together, SQL and ASP.NET. All right, so this says that how many classes we have which are overlapping and divided by how many classes, I mean in the prediction, how many classes we have which are overlapping correctly, divided by how many classes we have total for SQL and ASP.NET together. All right, so this is the overall process to understand this. So what I'm gonna do here, I'm gonna use that Jaccard similarity method here. So the first of all, I have to implement that one. All right, Jaccard score. So this Jaccard score, I have to implement it. And to implement this Jaccard score, you can see these here. We have to first find out the intersection and then divided by the, you know, the addition of those intersection. So we can do here, we can write here a method like def j underscore, all right, j score, and in this I have y true and then y pred. All right, then I'm going to say that here. So there is Jaccard, although the spelling could be something like this one. So this is actually correct spelling. We have something like this one. All right, so there we have you know, the Jaccard. So this Jaccard, thereafter we are going to write here np dot minimum. So it will say us that how much we are actually, you know, the intersection. So we have here np dot maximum. Once again, it says that I'm having here, it seems a good and excellent connection. Sometimes it connects very well and sometimes it get disconnected. I'm sorry, you have to face this one. So we have a np.maximum, and guys, please let me know if you are connected. All right, np.maximum, then we have y underscore true, and then y underscore pred dot sum. Sorry, so this is sum, and this sum is going to be along the axis 1. All right, superb. So this is how we can calculate the J score. Thereafter, we are gonna return here this J score. All right, so this is the method of returning this J score. Thereafter, I'm gonna use here another method which says that print underscore print score, and this print score takes here y pred and then CLF, so that I can tell you that which classifier we are using to print our score. All right, perfect. Let's go ahead, use the first line of print. There I'm saying that which CLF I'm using here. All right, and then I'm saying that here CLF underscore class dot name. Sorry, this should be like this one. Sorry. So this name will return that which classifier we are using here, OneVsRestClassifier. All right. Thereafter, I'm gonna use here once again print. All right. Jaccard score. And in this Jaccard score, I'm gonna use here a format. So in this format, I'm gonna write like this one, a format, and then I'm gonna say here J score, and in this J score, I have to pass here y underscore pred. All right, and then sorry, this should be the y test. So the first one, the y underscore pred. Thereafter, once again, I'm gonna use here. We have got here Jaccard score, and I'm gonna just use here a new line. All right, new print line. Perfect. Let's go ahead and run it. Thereafter, once we are done with this Jaccard score, then after this CLF dot fit, that's mean one fit is done. Then I'm gonna say here y pred is equal to CLF dot predict using here x underscore test. All right, and then I'm using here print underscore it's a print score, and in this we have here y pred dot classifier. All right, so the classifier is this one. Let me copy it and paste it here. Yes, Prem Kumar, yes, it is available, but I wanted to show you that why we need to use this Jaccard and how we can do these things. Otherwise, yes, it was available. So this method makes you comfortable that okay, how it is being used and how it is performing. All right, so we have here print underscore score y pred and then classifier is there. All right, perfect, superb. Let's go ahead and run it. Now if you run it, we have to wait whether we get the error or it is working good. So this says that I think something is wrong there. All right, so something is wrong there. Let me see what is wrong. It is not printing correctly here. This Jaccard score. All right. Oh, sorry. I think I'm missing here. So there should be a mean and then a multiplication with 100. All right. So this is the mean. Perfect. Let's go ahead and run it now. So we are going to see how much accuracy we are going to get here. Superb. In the first one, we are getting here a Jaccard score of 40. 100 is best, but we are using here a multi-label classifier. So sometimes it gets really very difficult to get that much of the accuracy which we get in general in our the classifier, multi-classes classifier. Alright, so linear SBC is giving us around 52% of the Jaccard score, which is really not bad for this data set. Alright, and which is good for this data set. Alright, now let's go ahead and see how you can do a model testing with the real data. So let's say if you have X like this one, how to write ML code in Python and Java. I have data, but do not know how to do it. So this is X, and for this X, we want to do a prediction in for our model, which we have just trained. So for that, I have to get here a TF-IDF. So I do here TF-IDF dot transform. Thereafter, I'm going to pass here this X. Now if you see this XT, this is a TF-IDF Vectorizer, which we have got there, and this is a sparse matrix. Now we can simply do here CLF dot predict, and if we do here CLF dot predict on this TF-IDF data, we get like this one. All right, so these are the one, that's mean these two classes are one. Now we have to also know that what are those classes. And to know those classes, you have to write here a multi-label dot inverse transform, and inside this inverse transform, we have to pass this CLF dot predict. Now it will show us that what are the label which has been predicted here, and it says that for this particular data, it has predicted here this Java and Python. All right, perfect, superb. Congratulations. You have really trained it, and you have got to know that how you can work. And apart from that, let me show you a few more things here. All right, I was talking about the TF-IDF Vectorizer here, how we can do this. Let me show you here another feature. The another feature which we can play with, that is the n-gram range. By default, this n-gram range is limited to 1, 1, but let's go ahead and select it 1 and 2. And this max feature, I'm also gonna increase it to, let's say, 5,000. All right, perfect. Let's go ahead and run it, and then see after this. Let's go ahead and see how much accuracy we are gonna get if we increase the n-gram range. All right, based on that one, then we can identify that which method is doing best for our purpose. All right, so of course, as I told you at the start of this lesson, if we do with the large feature set, then it will definitely take time. So here we have got x.shape. Now we have here 5,000 data, but do remember this 5,000 will really take a lot of the time. All right, so now this score is running here. Let's go ahead and see, and I think it is increased. All right, it has improved. For SGDClassifier, earlier we were getting around, I'm not sure It was 42 or 43%. Guys, if you remember, please let me know. All right, so logistic regression is saying that we have to increase their maximum number of iterations so that solver can converge, and superb, right? I mean, really superb. So we have increased our accuracy almost 8%. Earlier we had here, you know, 58 point. I think earlier we had a 51%, and now we are getting here a 58%. Guys, please let me know if you really like this method to play with these n-gram. All right, and if you feel that it is really good, so I can do some more testing here to show you that how you can test your, how you can increase your accuracy. In meantime, Prem Kumar Jha is asking about, can you explain clf.class.name? Yes, Prem Kumar, definitely I would like to explain you. For that, you can see here one versus rest. All right, here we have one versus rest classifier. So if you open here this Scikit-Learn multi-class one versus rest classifier, then what do you see there? So these are the input parameters, and there are some other attributes, and thereafter let me show you here. It has some those internal variables which we can access, and those internal variables we should be able to see those variables. Are we able to see those here? All right, so those are not visible here, but I can explain you, like let me come back to here once again. So with this one, actually, where is it? All right, so with this one we are getting here the name of classifier, because this one versus rest classifier is taking the classifier, and this classifier is, we are feeding here SGD, logistic regression, and SVC. So this CLF dot underscore class underscore and this name says that which classifier is being used in this one versus rest classifier. All right, perfect. In meantime, let's go ahead and play with another analyzer which we had, character. All right, if you see there, I think we had a car. All right, so with this character n-gram range, I'm gonna put here 2. Okay, 2 is okay. Otherwise, let me put it 3. I think 3 will be, a lot better than the others. So once again, it's gonna take some time. Let's go ahead and rerun it, all those things again. I mean, really, this is great to test the models, how these models are performing. All right, so what it is doing here? Okay, the TF-IDF Vectorizer is being done. Yes, Prem Kumar, so this is a inbuilt feature. I think now the internet connection should be okay. All right, so here how this n-gram is working. In meantime, while it is training, let me tell you. Let's say if you have some word here, all right, like this one. Let's say you have, all right, let's say you have this one. So in this, if we select analyzer character, then it will do first L E T S. All right, then there is a space. So all those things will be done first, that is the 1 gram. Then for 2 gram, it will take these LE, ET and TS together, and like that it will also do for for a trigram and 4 gram, like those. All right, so in meantime it is okay. So here it says that the accuracy is decreasing here for our character classifier. And how many features it has? It has a 5,000 feature once again. All right, so for this particular feature and for this particular problem, the character boundary is not working for this one. Prajwal Bhandari is asking about can you explain the transformers? Prajwal, I have a very good course on the advanced machine learning algorithms like BERT, transformers, digital BERTs, all those. You can watch those, you can see that here. We have a bit, let me send you a link here, https bit.ly/. There I have, I think the name of that one is BERT_NLP. Alright, so this is the course here. You can see in this course I have explained about the transformers and pretty much advanced algorithms. Alright, perfect. So once again it says that solver convergence is not being done here. So solver is not converging. So why it is happening? Let me complete this training. So I'll show you here. Alright, so for the logistic regression, Jaccard score is here 40. Let's go ahead and wait for the linear SVM as well and see how much accuracy we are getting here. Thereafter, we can again come back to, let me see here, we can come back to once again at word analyzer. Alright. Thereafter, I'm also gonna fit it to 2. Thereafter, one more thing I would like to show you here is that if you use a stop word removal, then how our accuracy is gonna change. Alright, so the linear SVM, for a linear SVC, we have got here accuracy, better accuracy. So that is a 58.86%. So we are getting here a better accuracy in this case. Alright, one more thing let me do here. Let's go ahead, copy this one and put that here. And now I'm gonna select it only for SVC so that I can do here fast training and testing. Alright, so SVC says that that is for 5,000 features it is producing better accuracy, but in meantime I'm also gonna change it here and I'm also gonna show you how you can test it with some other feature. And some other features like we have tested the analyzer, max feature, ngram. I think we should have here a stop words. Alright, here I'm not able to see this TF-IDF Vectorizer. So that one is not coming. So that is why I'm gonna put it here. Alright, so in this what is happening here? In the TF-IDF Vectorizer, we have these input parameters. So auto correction was not, auto suggestion was not coming here. That is why I came to here. So what's happening here? We have, these are the input, encoding, decode. So I'm interested pretty much, we have tested this analyzer here in this stop words. All right. So I'm going to select here this English stop words. So if we select English stop words, what happened? The dictionary will not prepare a stop word. So stop word will be discarded, and then I'll show you how the accuracy are actually improving. So stop words there, and then there we have English. Let's go ahead and run it. So in meantime, it is while running. Let's go ahead and run these things. And I want to run this SVC, but I don't want to this one because SVC is constantly producing a better result. So for that purpose, I'm not gonna test. All right, so we have increased accuracy by removing stop words. Now let's go ahead and do some more testing here. Guys, one more thing, if you are really liking this, the testing, the parameters, then let me know. Otherwise, I'll stop this video here. And one more thing, you might be wondering that there are many other methods like a grid search. All right. And A grid search method is also a very good method to doing all those things. And if you are interested in a more algorithm, what do you say that? Algorithm optimization, then definitely I think, let me show you that actually. In the algorithm, I'm talking about here algorithm optimization. All right, so I have here a course that is a bit.ly / this one is intro _ NLP. So this is the introduction NLP course, and in this NLP course, all right, you can visit it by typing let me paste it here, https bit.ly / there we have intro _ NLP. All right, so this is the course, and in that I have explained these things in the pretty much detailed explanation, and I think those are here. Let me show here. All right, so these fine tuning of machine learning algorithm. So the way I was showing you that how you can improve your accuracy, because if you remember, we started with the 51% of accuracy, but by doing some testing and settings, we had increased it to a 61% of the accuracy. That is a huge improvement. So there are many ways. We have just played here just few parameters, but in this video I have shown you can play with many parameters, like how you can do these factorization, etc., and then how you can do hyperparameter tuning so that you can improve the accuracy. And by going through these lessons, you will learn how you can use grid search and how you can improve the accuracy. All right, and then I have also many other ways to learn, to make you understand how you can deploy your ML models, how you can learn the word embeddings, club vectors, how you can do the resume parsing and all those things. And the working codes for all the videos are available there, and you can download the resources from this resources section. All right, so there we have got a 61% of accuracy. Let's go ahead and do some more changing here. So the change which I'm gonna do here, I'm gonna put here n-gram range to 3 here, and this max feature I'm gonna increase it to a 10,000. And definitely it will take a lot of the time, because we are doing here n-gram 3 and max feature 10,000. So it's gonna take some time, but let's go ahead and see how much accuracy now we are gonna get with this one. Thanks, Prem Kumar. Thank you so much. All right, so I think a TF-IDF is still being done. So it is happening because n-gram range is here 1 to 3, and the maximum feature was 10,000. So we have also increased the maximum. We have increased this maximum feature as well. Now this has started. Now you see there, superb. This is superb. We were at 61.2% accuracy. Now we have reached here 62.42% of the accuracy. So this is the one way. There are many more ways we can do. We can also play with some other parameter in this linear SVC as well. All right, so in this linear SVC, let me copy it from here, from there to here, so that we can play with those methods here. I'm not getting that auto correction. Not sure why, but if you see there, I think, do we have C there? So we have this C is inverse of regularization. All right, and for this C, I'm gonna use here by default it is 1, but I'm going to use here a 2, and for C is equal to 2, I'm going to see here how much accuracy we are going to get. All right, do remember, if you are looking for any automatic testing, then you can see there this fine-tuning ML algorithm. So there I have shown you how you can do those testings. All right, I think it's 62.54% of the accuracy, but if we make it 3, let's see and what happened here. In meantime, we can also copy this one and then we can put it here, and then we can play with more number of parameters there. All right, so the accuracy is decreasing here, 61%. Let's go ahead and check with C is equal to 1.5. All right, so by default, the penalty is here L2, but we can also test it with L1 penalty. And this C is regularization parameter, and this is strength of regularization, but inversely proportional. All right. And a class weight, we can also use here a balanced class weight. All right, let's go ahead and test this one if it increases this J score. And all right, so this one has increased the accuracy a little, and now we have reached here 62.80 accuracy. And let's go ahead and test this one. Class weight is equal to, I'm going to use here balance. Is it balance or balanced? Let me see here. It's actually balanced. All right, so for balanced, how much it is gonna make? Let's see. While it is training, let's go ahead and show you. All right, so for balance, the accuracy is decreasing a little. So let's go ahead and remove it. Thereafter, one more thing, I'm going to test it, then I'll stop this video. By default, this is penalty selected as L2, but I'm going to test it with L1 as well. So if you select here L1, then see what happened here. It's penalty. Is it wrong? I'm not sure. Oh, sorry, it's this one is penalty. All right, so now I'm going to use here a penalty is equal to L1. But when we do the penalty is equal to the L1 and loss is equal to the squared hinge are not supported when dual is true. All right, so I have to set here this dual is equal to false when we want to use this penalty. All right. All right, so we have to wait for a while it is completing. It might take a time. Linear SVC is taking some time. All right, so in meantime, guys, if you have any question, you can ask. After the testing this one, I'm gonna stop this video. I think it has been almost an hour. All right, so it should be done here. It should be done, and it's taking time. All right, keep watching, keep watching. Okay. All right, so it is taking time. I think it will take some time. So in meantime, you have got the idea. Wow, I mean, this is really superb. This is superb. I mean, we started with a 51% accuracy, and then now we are almost reaching at 64% of the accuracy. I mean, do you really believe this? I mean, we started with the lowest of the accuracy level. Thereafter, we kept increasing the accuracy. And there are a lot of the scope to increase this accuracy. If you select any of these methods which I have shown here, you can definitely increase the accuracy. you can go beyond the 64% of the accuracy. All right, superb. So guys, thanks a lot for watching this video, and I'm gonna stop this one. I mean, really, it has been a fun to work with all of you. All right, bye bye, and see you in some other lesson.